So the other day, I was remarking to fellow envisioner Sean Grigson about how easy it was to create and consume zip archive files in Lucee CFML, to which he responded that Lucee also supports the zip virtual file system. Now, the virtual file system has been supported by ColdFusion since I think version 10, and I haven't looked really into it since then, and I don't think I've ever looked into the zip version of the virtual file system, so I thought it'd be fun to take a moment here and play around with it a little bit. The virtual file system, as a refresher, is essentially a file abstraction that allows us to treat a variety of resources like files and directories in our local file system. And in the case of the zip virtual file system, it essentially allows us to write to and read from a zip archive file the same way we would write to or read from a directory in our local file system. The zip virtual file system works by creating a physical path and a virtual path. And it works here by first defining the zip schema of the virtual file system, then followed by the physical file path, which means that this is the actual file path on our local file system to the zip archive that we want to create or work with. Then the exclamation mark, which delimits the physical file path from the virtual file path, such that everything after the exclamation mark, or the bang here, defines zip entries or entries within our zip archive, so files contained within the zip archive. And that virtual path is defined relative to the root of that archive file. So once we have this zip virtual file system prefix, we can then use it to perform standard file input-output operations. So for example here, I'm going to write a file to the archive.zip file, and you can see that I'm prefixing my file operation path here with the zip file system, and then this /readme, this is the virtual path, right? This is coming after that bang, so this is going to be relative to the root of that archive. So this file entry is going to be in the root of my zip archive. Then I'm going to create a couple of files in subdirectories. Now, because this is an abstraction over file I/O, it still is restricted by standard file I/O constraints. For example, I can't just write to a directory within the zip archive that doesn't exist yet. So I have to create a subfolder here, files/poems. I have to tell it to create the path if it doesn't exist. And then once that directory exists, I can then, right, you can see it's all here, I can then write files to those. So I'm just going to write a couple of poems here to the subfolders. Now that was writing individual files. We can also copy directories out of our physical file system into our virtual file system. In this case, I'm going to take a haikus directory, and you can see I'm going to copy it into the zip virtual file system. At a subdirectory, I'm going to tell it to create those paths, right? This file haikus path if it doesn't exist. And now that we've populated our zip archive, I can use standard file I/O operations like directory lists to look inside that zip virtual file system and see what files exist. So in this case, I'm telling it to look in the root of the archive and then recurse down. This is going to give us full file paths within our zip archive, but I don't want to output the entire file path, so I'm going to map that file list onto just the virtual file path. So if you remember that our virtual file path, or a zip virtual file path system, virtual file system has two parts. It has the physical part and the virtual part separated by the exclamation mark. I'm just going to get everything after that exclamation mark. And then I'm going to go ahead and dump those out. And then just as a funsies, I'm going to take that archive file and extract it. Again, this is just how easy it is to use zips in Lucee, which is pretty exciting. Anyway, so again, just to sum up here what we're doing, we're creating a zip virtual file system, we're populating it with a number of files, and then we're using the directory list function to query that zip virtual file system and then dump those file paths to the browser here. And when we run this in the browser, here's what we get. Here's our zip virtual file system. These are all paths now that have been trimmed to just the virtual portions, meaning we've stripped off the physical file portions, which, you know, actually, since this is a demo here, let's just return the path here. So let's not strip anything out. You can see what happens. You can see here we get the full zip virtual file path schema. We get the location of the physical zip archive in the file system, and then we get the virtual file path or the zip entry contained within that zip archive, right? So let's take that out again, and you can see now this is just the stripped down version. So these are the files now contained within the zip archive, which we were able to create and populate using standard file I/O functions, file write, directory create, directory copy, so on and so forth, all thanks to the fact that this zip virtual file system essentially smooths over the complexities of a zip archive behind a file-based abstraction. And I don't know, pretty cool. Again, I don't quite know why I'm so enamored with the creation and consumption of zip archive files in Cold Fusion. I think it's just that it makes it so easy to export and package data for consumption in another system. But anyway, fun stuff.